back. Problem 3. The shelf life of a battery produced by one major company is known to be normally distributed with a mean life of 4.5 years. So the mean is 4.5. And standard deviation of 0.9 years. Standard deviation of 0.9. Use the expanded empirical rule. What is the probability? Fewer than 3.6, more than 7.2, between 2.7 and 6.3 years. So what is the expanded empirical rule? It's the same picture we have seen before. Where did it go? There. All right. So this is the expanded empirical rule. All right. So within one standard deviation, you have 68% and each side gets 34%. Within two standard deviations, you have 95 percentages, which means 13.5 here, 34 here, so on. And the last part, mind you, between three standard deviations, you have 99.7 percentage. In other words, here and here, put together you have 0.3. Okay, 0.3 will make it all of 100. So beyond this entire range, you have 0.3. So 0.3 has to be split into half. So 0.15 to the left, 0.15 to the right, and that's how you get 0.3 on either side. So this is your expanded empirical form. All right. So now you're going to use that to look at fewer than 3.6. So you need to know how far 3.6 is from your mean. How many standard deviations is it away from your mean? Okay, so I need my workspace here. There is my workspace. All right, so let's get the numbers put in. So mean 4.5. Okay, and standard deviation of 0.9. Okay, so I don't know why I have this arrow over here. So let me erase the arrow so nothing is confusing. Okay, so 0.9 is your standard deviation. So if I say 4.5 minus 0.9, that gets me 3.6. So 4.5 minus 1 standard deviation gets me 3.6. So this is 3.6. Okay. If I go one more standard deviation to the left, I get 2.7. So this is 2.7. If I take away one more standard deviation from the mean, I get 1.8. So this is 1.8. So these are all the numbers starting from the mean, that is mu. One step left, one more step left, one more step left. So now starting from the mean, I will add one step each. Okay, add one standard deviation each. So that gets me 5.4 here. And if I add one more standard deviation, I get 6.3 here. And adding one more standard deviation, I get 7.2 here. Okay, so mean, 3 numbers on the right, 3 numbers on the left. Now that's important because you have mean and 3 numbers on the left and 3 numbers on the right. Okay, so these numbers, how do you get? By taking the mean, subtracting standard deviations 3 times and adding standard deviation 3 times. So now you have the numbers you need. Fewer than 3.6 years. So 3.6 is here. Fewer means less than 3.6. So you want to go everywhere to the left. So let's look at our expanded empirical form. So 3.6 is one step away from there. So you are here basically. So you want all this area, 13.5 plus 2.35 plus 0.15. So that's what you are going to add. Okay. So to the left, 13.5 plus 2.35 plus the last one is 0.15. Okay. Now next one is more than 7.2. Where is 7.2? 7.2 is here. All right. So more than 7.2. So I better delete this arrow. All right. And more than 7.2 is to the right of 3 steps away from the mean. So mean is here. 3 steps away is here. That's why 3 sigma. More than that gets me 0.15. All right. All right. Between 2.7 and 3.6. Between 2.7 and 6.3. So 2.7, so let me erase this arrow out here. Okay. So between 2.7 and 6.3. 2.7 and 6.3. So I'm looking at this much. Okay. So how does that look like? From mean, I go 2 steps to the left and I go 2 steps to the right. So between these two. So let's look at 2 steps to the left and 2 steps to the right. So between these two, well, that's a 95%. Okay, between 2 standard deviations, you have 95%. Oops, I got kicked out. Oh, I'm sorry. So they don't want it, they don't want percentage, they want in decimal. All right. So all of this is percentage, remember? So they want probability in decimal form, means you want to divide by 100. Okay. They don't want percentage, so this is percentage. Wherever you see percentage, you want to divide by 100. You don't want percentage, you want to divide by 100. Okay. Okay, now that's correct. That completes section 7.1. We'll come to the next in section 7.2. Until then, bye.